I am a graduating PhD student in the computer science department here at Berkeley, advised by Professor Neil Salehi. And today I work broadly on human-computer interaction and machine learning and data systems. And today I'm going to be talking about designing for verifiability in machine learning systems, specifically focused on machine translation. So let me share my slides. Let's see. Okay, we did it. So yes, designing for verifiability in machine learning systems. And I'm going to start out my talk by borrowing an example from Professor Manish Agarwala from Stanford. And in this example, your goal is to get DALL-E to generate Stanford Memorial Church in the style of Blade Runner, the movie. So we see an image of Stanford Memorial Church on the left and an image of Blade Runner on the right. And so Professor Agarwala tried to do this, and this was the first prompt he put into DALL-E. So he put in Stanford Memorial Church with neon signage in the style of Blade Runner. And this is the image he got back. But he says that this isn't really what he had in mind. And so he tried again, edited the prompt a little bit and got this. This was maybe a little bit better, still not really what he wanted. So he tried again and again. And then eventually he writes in an accompanying blog post to this talk that after 21 iterations and several hours of somewhat randomly trying different prompt words, he decided to stop. He said the resulting image isn't really what he had in mind. And even worse, it's unclear how to change the prompt to move the image towards what he did want. And so he concludes, this is really frustrating. So frustrating, in fact, that the title of this talk and post is Unpredictable Black Boxes, a Terrible Interfaces. This is a really awesome talk. I really highly recommend checking it out. There's also a blog post. I've got links on the slides here. And I want to build on his example with a second example. And this time, your goal is to tell your patient who speaks Chinese not to take their kidney medicine until after their follow-up appointment with their nephrologist. And now we can turn to another freely available AI tool, this time a machine translation system. And maybe our first attempt is to put in hold your kidney medicine until you have a chance to speak with your kidney doctor. And this is no longer the actual output that you would get from Google Translate, but this was something that Kung and colleagues found in 2019. This would have been what you got. Now, should I iterate on this input? If I were to iterate on it, how would I iterate on this? It turns out that it would have been really important for me, at least in 2019, to iterate on this, because this translation does not at all convey what we wanted to say. It actually says, keep taking your kidney medicine until you talk to your kidney doctor, which you can imagine would have really serious consequences if this was used in the real world. And so I would add to Professor Agarwala's point here that unpredictable black boxes are terrible interfaces, and they're really terrible interfaces if you can't verify a model's output. And I want to briefly convince you that this is quite common. Another example of this kind of task is question answering, right? Maybe you have played around with ChatGPT and you asked it a question, and you're asking this question because you don't know the answer. And you might have seen something like this, some really confident sounding, apparently correct output that is actually completely incorrect, but you wouldn't know that unless you already knew the answer. Another example is code generation. A friend of mine was recently looking for a Python function that would tokenize JavaScript code. And he searched Google for this, and he had their new generative AI feature turned on. And it gave him back this, which to me looks like reasonable Python, right? That looks Pythonic. And the output is exactly the output that he's looking for. But it turns out that this code doesn't work at all. The AST module doesn't tokenize JavaScript. The function it would use for tokenizing isn't even tokenized. It just completely doesn't work. But again, if you're searching because you don't know how to do this, you're going to have to go do some poking around to figure out what's going on here. So you got to be careful with these models, right? No, of course that's not the end of my talk. That would be a ridiculous thing if we just said, oops, sorry, be careful, right? No, not right. That's exactly what the companies are doing, right? So when Meta released Galactica, their LLM for science last year, they said, it contains the world's knowledge. Except don't read the fine print, because you'll see that there's actually no guarantees for truthful or reliable output, and you should never follow advice from a language model without verification. Now, this is not really the best example because this was taken down pretty quickly because people realized that an LLM for science isn't very useful if you can't rely on its output ever. But if we go back to that code generation example, this was just from last week. And if you look at the fine print here, you see it says use code with caution. And I don't really know what that means, so I clicked on learn more. And it says use responsibly. Generative code features are still experimental, you're responsible for your use, okay? So use discretion and carefully test and review all code. Good, fair enough, we should always be testing and reviewing our code. But what's wrong with this kind of use responsibly argument? It still just doesn't totally sit right with me, right? I mean, one point is people aren't gonna do this. We know that people aren't super responsible with their consumption of information online. It's not really realistic to think they're gonna go out and verify every single output they get, especially as these models become more popular and widely used. Another challenge is that it kind of defeats the purpose of using the system in the first place, right? I go to ChatGPT because I want a quick answer to a question. If I need to go then verify that in an independent source of information that's more reliable, why aren't I just going to that independent source of information to start with, right? And the third point, and I think a point that sits especially well with human-computer interaction researchers, is that it's shifting responsibility for failures from the system onto the user. And that's not really what we think of as good user interface design. And we have a lot of knowledge about how to design good user interfaces and user experiences. For example, this is a set of usability heuristics that's pretty widely used in UI and UX design. And I'm not going to make you sit here and read through all of them. There's two that I really want to highlight. So the first is number 5, error prevention. And this one says, good error messages are important, but the best designs carefully prevent problems from occurring in the first place. And the second is number 9, which is that we should help users recognize, diagnose, and recover from errors. And they say that error messages should be expressed in plain language, precisely indicate the problem. And I think this one's really important when it comes to generative AI systems. We should be constructively suggesting a solution. And so I think it's pretty clear that just kind of having fine print that says, watch out, is not really meeting these principles that we know through decades of developing computational systems are really important for good usability. I want to take a pause now to kind of map out where the rest of this talk is going. So first, I want to talk about why is this so hard to design? We're not talking about, I don't know, Joe down the street designing an interface. This is Google and Meta. Why are they putting out these models? They've got brilliant minds. Why is it so hard to make this usability really good? Second, I want to talk about what I think we could do better. And then third, I'm going to demonstrate that through Cephalo, which is a system I've been working on for more verifiable authoring of multilingual discharge instructions. So to demonstrate why this is so hard, I'm going to introduce one more concept that we use a lot in HCI, and that's the gulf of execution and the gulf of evaluation. So say we have a user here, and they have some goal, and they've been given a system that they've been told is going to help them achieve this goal. Now, what do we need to figure out if we're the user to use the system to meet our goal? First, we need to ask, how do I use this system? How do I express my goals to it in a way that it's going to understand? And then once we've done that and the system gives us back some output, we then have a second question, which is, how can we tell that it did what we wanted, what we wanted it to do? So how do we take its output, interpret that, compare it to our goal, and figure out if our goal has been met? And so this first one here on the top is what we call the gulf of execution, the gap between our goals and how we need to express that to the system. And then the second one is the gulf of evaluation, or how do we evaluate the system's outputs and compare that to our goals? To understand these concepts a little bit better, let's go back to the examples that I started with, right? So the first one, we were trying to use an image generation system to generate an image of Stanford Memorial Church in the style of Blade Runner. And so DALL-E, we were using DALL-E here, has a natural language interface. So we express our goal in natural language. We say Stanford Memorial Church with neon signage in the style of Blade Runner. And then the system gives us back an image. That's the output format here. And now we were able to look at this image and say, compare it to our goal and say, well, no, that doesn't really meet what I was thinking about. So barring potentially some accessibility concerns, the gulf of evaluation here has actually been bridged quite well. We can take the output, compare it to our goal, say, no, don't like it. But then we run into a challenge when we go to try and get the system to do something closer to our goal, right? we don't really know how to change the prompt to get closer to what we're imagining. And so the gulf of execution here is not bridged well, and that's why we run into these usability issues. What about our second example, the translation example? So here, again, we've got a natural language interface. We write out our goals in natural language, say, hold your kidney medicine until you have a chance to speak with your kidney doctor. And this time we have a natural language output as well. So this time the output is in Chinese. And now we have an even bigger challenge, right? Because now we look at this output and we actually have no idea how to compare that to our goals. So the gulf of evaluation is also not bridged well. And then we've got the same problem as before, where we don't really know how this model works in the back end. We don't know what would be translated well or not. So we don't know how to bridge the gulf of execution either. Now I want to bring back those design principles that I mentioned earlier, because I think they map on really well and have some parallels with these two challenges. So the first was error prevention, right? We're not helping the user prevent errors because we're not telling them, hey, this is how the system can be used and this is how it can't be used. We're not really telling them anything. And we're also not helping users recognize, diagnose, and recover from errors because the outputs are in a language that often the user can't understand. Of course, sometimes you're using Google Translate or a machine translation to translate between two languages, but that's not really the main use case. Okay, so that's hopefully convinced you that this is really hard to design for. This is not an easy task. But what could we do better? And I think there are two really promising directions here. They're a little high level, but I think that two broad directions are to help users craft good inputs to these models and help them verify the outputs. And I'm going to talk a little bit more about what I mean by that. And first, let's start with crafting good inputs. What does it mean to craft a good input? In the context of machine translation, you might think, well, maybe we should use correct spelling and grammar. Maybe we should use simple sentences, avoid slang, idioms, and metaphors. And you could think about a lot of different rules that we could come up with like this. And I've actually seen in my prior research that people do have theories like this about machine translation models specifically. So they'll tell you that they're trying to use correct spelling and grammar, they're trying to avoid metaphors. But when you're using these systems, you're not really thinking about that. You're not closely proofreading your inputs. And so people will try to follow these kinds of rules. They'll even think they are doing a good job of following these rules, but they'll still throw in idioms they didn't even register as an idiom and that kind of thing. So that's one challenge with this approach. Another problem here is that these models change. These models are updated frequently, not always in a way that's transparent to users, and they might apply differently across different language pairs as well. So it's not really clear how we should be helping users update their mental models of how to use a translation system well if we're thinking about these kind of rule-based approaches. So a little bit more general way of thinking about this is that we want to help users craft inputs that are close to the model's training data. And I thought about this a lot as I was thinking about translation, the usability issues around machine translation. And I got kind of frustrated and preoccupied with this because I was like, we have these big data sets of translations, high quality, presumably. There's definitely quality issues in training data, but we have these large training data sets of translations. That's how we built these models to start with. We know that users are likely to get better translations if they're writing in a way that's closer to the training data. But users have no idea what's in the training data. And this just seemed like a missed opportunity to me. But of course, it's not really quite that simple because these training data sets are huge, right? Even the people developing these models and building these data sets, they don't necessarily know what's in them. And then there's this question of kind of like, what does close even really mean when we're talking about language data at this kind of scale? And so I started thinking about a little bit more narrowly defined notion of close to training data. And it was inspired by the concept of a translation memory. And a translation memory is a feature that's really pretty standard in tooling for professional translators these days. And it's essentially a database of high quality translations, similar to kind of a training data set. And the way that it's used in computer aided translation software for professional translators, for example, this is from a product called Lilt, is that translators are often given a bunch of tasks to do, and sometimes something that they get will be very similar to a translation that they have already done. And so it's not exactly the same, but Lilt here, for example, would surface that and say, well, you need to translate the hares and the tortoise. You haven't translated exactly that sentence before, but you did do a translation of the hare and the tortoise. So maybe you can use that, start there, and that would help you get through your translations a little bit more quickly. So this seems helpful, right? If you're a professional, you speak both languages, you can quickly edit the translation. But there's not really a good equivalent for just kind of a general end user machine translation system. The closest that I can think of is this feature that is in Google Translate. It might be in some other products as well. This is one that I've seen, where if you put in a sentence that they do have a stored community verified translation, you might see this little symbol pop up. And if you hover on that, it'll say this translation was marked as correct by Google Translate users. So far, I have only ever found this on very standard sentences. Like if I had changed this to my first name is Sam, it may have gone away. And so it does give you a sense for a small number of input sentences that you've got a good translation. But there's no really real way of knowing what's in there, when you're going to get this, or how to change your input to then get to something that's being community verified. So I don't really think it totally meets our goals. And so I'm interested in kind of like, what can we do if we had a translation memory? But it's a little bit difficult to think about this at the scale of all the different things that people use machine translation for. So I'm going to switch gears for a second and introduce an application context that I've been working on. And that's hospital discharge instructions. So to give you a sense of what these instructions contain, these are instructions that a doctor will send home with a patient when they're leaving the hospital. And they'll usually say, dear so-and-so, you came into the hospital for this. We gave you these treatments. Maybe you have this diagnosis. And really importantly, it'll tell the patient what they need to do when they go home. So use your medication changes, maybe you have some follow-up appointments. And then, you might want to come back to the emergency department if you experience these symptoms. We're working with emergency department here. Of course, there's some variety across different specialties. So these instructions are important for making sure the patients are taken care of at home. But for patients with limited English proficiency, there's some major challenges in getting them this information in their preferred language. And for discharge instructions in particular, timing is a really big challenge because the doctor's usually writing this kind of right before they're sending the patient home. You don't want to be keeping the patient back in the hospital while you're waiting for a translator. And availability of translators is also a major challenge. So there might be an interpreter available on the phone, but often there's not someone there to do a written translation. And so patients often get sent home with these just in English, or maybe increasingly so, with some hesitation, a doctor might put this into Google Translate and give the patient some kind of disclaimer of, here's a translation, it might not be correct, kind of the use responsibly argument. But getting people accurate, appropriate translations of these instructions is really important. Research has found that patients with limited English proficiency are seeing worse clinical outcomes across a wide range of post-discharge issues. Of course, we can't tie this, causally to discharge instructions, but I think it's clear that offering people accurate information in their preferred language is really an important and valuable step to trying to address some of these health disparities. Two interesting points about discharge instructions that I want to highlight. One is that hospitals have a lot of pre-translated patient education materials. For example, maybe in your EHR, there's kind of these standard templated instructions that you can kind of give to a patient, and they might be available in a bunch of languages. But if you don't speak that target language, you're basically given the option of using it exactly as it's written or not at all. There's no flexibility there. And the second point is that discharge instructions are relatively structured and repetitive. I kind of showed you the general structure. You can imagine that changes. You came in for this, you came in for that. But there's often a lot of structure and repetition there in terms of the content in these instructions. So based on those two, and what I said earlier about the idea of a translation memory, I started thinking, what could we do if we had a translation memory specifically designed for discharge instructions? What would that enable? Remember that our goals here are to help users craft good inputs to a translation model and help them verify the translation outputs. And what I'm going to show you is that if we have a translation memory for discharge instructions, we're able to transform the task of translation into a retrieval task. And that with a retrieval task, we get a clear definition of good inputs and verifiable outputs for free. So back to our roadmap quickly. We've talked about why this is so hard to design good interfaces to generative models, especially when you can't verify the output. And now I've talked about one way that we might be able to do better. So now I'm going to introduce Cephalo, which is a system that I've been building around a custom translation memory for discharge instructions that I think offers a more verifiable alternative for offering multilingual discharge instructions. There's two core components of Cephalo. The first is this custom translation memory that we've been talking about. And then the second is an intent matching model. You can also think of this as basically a retrieval model. Now we do have prototypes of each of these. We have an initial translation memory. It's got 163 templates and over 800 terms in it. And we've also been playing around with different model architectures that could actually implement everything I'm about to talk about. But in this talk, I want to keep it a little bit more abstract because I'm really trying to drive home what this enables from an interaction perspective. All right, so let's imagine we're using Cephalo. And we'll go back to our familiar hold the kidney medicine until you have a chance to speak with your kidney doctor as our input sentence. If we put this in, it goes into the intent matching model. The intent matching model interfaces with this custom translation memory. And it produces some entry from the translation memory. And because this is a translation memory, it's a bilingual resource. It's got English, and it's also got professional translations into some target language. In this case, we've got Chinese. That have been professionally done and verified, so we can assume some arbitrary level of translation quality. And the important piece here is that because we have this in English, the user can look at the source sentence and the translation memory match and directly compare and verify that it conveys their intent. Of course, this is still a model. This can still make mistakes. So it's possible that the intent matching model makes a mistake and gives you back a sentence that isn't what you want. For example, maybe it's the same mistake that Google Translate made earlier with keep taking your kidney medicine. But the key difference here is now the user can look at this and immediately identify that something has gone wrong. And not only identify the error, but they could actually go and look in the translation memory and say, okay, that's not what I wanted. What else have you got for me? I want something else. So I think we're in a better place so far. But of course, the translation memory is limited, right? We could make it a lot bigger than the one that we have right now, but it's still always going to be finite. And so we can expect that there's going to be some settings where the model doesn't find a match. And it's not an error, there's really just no good match available. And we're not really sure what we're going to do here yet, right? And so we were concerned that this is kind of the limiting factor for this idea. Right, the field of information retrieval is very mature. We think we can probably do something fancy and get some good outputs. We've played around with different models. The matching part is doable if there's a match available. But really, the limiting factor here is it possible to build a translation memory that's going to cover a wide enough range of intents that really this is usable in practice? And so to investigate this, we ran an Oracle evaluation on 25 discharge instructions. And what I mean by Oracle evaluation is that we had a human go in and say, here's an input sentence, what's the best match available in this initial translation memory that we have? You can see what that might have looked like on the right. Kind of here's a template that could be easily filled in to match the input sentence. Or maybe for the second sentence here, we just don't have anything that's a good fit at the moment. And then we sent each of these matches to 3 different physicians who rated it based on how much of the meaning is conveyed, how much of the meaning of the source sentence is conveyed in this template. And we saw that 43% of the matches conveyed all of the meaning. So that's good. 20% conveyed most of the meaning. This was on a 5-point scale. But that still leaves 37%, which conveyed some, a little, or none of the meaning. So that's not so good. That means that we are in this position 37% of the time. And so we're thinking, okay, we could probably improve the translation memory, make it a little bit bigger. But we went and did an error analysis, and it really looked like about half of the time in those errors, it's not really so easy to just add a new template to the translation memory. It was really something a little bit more specific and customized that just doesn't really fit this setup very well. And so what can we do in that case? There's a couple different options. One is just turn to machine translation. That was kind of the baseline that we started with. That's an alternative. It doesn't have as much verifiability, but performance might be pretty good on a high resource language. So that's one option. Another option is to wait for a human translator. A third option is a combination of these. Maybe we use machine translation, send the patient home, also send it to a translator and follow up with the patient if there's any problem. But maybe there's something else that we could do here that's a bit better. So just reiterating what we found so far, if we have this translation memory for discharge instructions, then we can transform translation into a retrieval task. And that gives us a clear definition of good inputs. It's inputs that are represented in the translation memory, and verifiable outputs, because we have professional translations of everything in that translation memory. But we need to improve flexibility. Maybe one initial thought for flexibility that maybe some of you have thought already is fine-tuning, right? We've got this data set. Why don't we just fine-tune a translation model on this translation memory and then use that when we don't have an exact match? Some pros of this would be open-ended inputs. So it's ultimate flexibility in terms of inputs. And it's probably going to be better performance in the baseline model. So that's good. But there are some pretty major cons, I think, in this context. One is that it would require a lot of ML expertise to implement this, update it, maintain it, which might be a big burden in deployment. And two, it kind of runs into the exact same usability issues as the baseline machine translation model, right? It's not really clear what close to the training data means anymore, and it's not any more verifiable than the original machine translation model that we would have been dealing with. So instead, I've been looking into retrieval augmented models as an alternative here. And to introduce retrieval augmented models, I've got like kind of a typical neural network setup here, right? We've got some training data. We use the training data to build a neural network or to train a neural network. And then we use that neural network to make a prediction at test time. So we can think of this as parametric memory because the parameters of the neural network are learning to hopefully not completely memorize, but basically memorize the training data, and then also gives us generalization and new inputs. But the insight behind retrieval augmented models is that sometimes your test input is actually pretty close to the training data, or at least could benefit a lot from some of the data in the training data. For example, if you're asking a factual question and you're training on Wikipedia, it's possible that there's a segment of text in Wikipedia that actually contains the answer that you want. And so rather than relying only on parametric memory, we can augment this with non-parametric memory, which is basically a fancy way of saying, let's take some of the training data and actually use it directly at test time. And this has been studied across quite a wide range of tasks. And in the related work of this paper on the left here, they've summarized that retrieval improves performance across a variety of NLP tasks, including open domain question answering, fact checking, fact completion, long form question answering. You get the sense here, a lot of different tasks, including, importantly, translation. And so what does this look like a little bit more in practice? It could mean a lot of different things. For example, we could retrieve a bunch of examples that might be helpful and concatenate them to our input. We could retrieve a similar example input-output pair and just edit the output. I think this kind of approach could be really useful for kind of the template-based approach that I was talking about earlier. We take a template, we still need to edit it to get a final translation. And then another way of doing this is to retrieve a bunch of examples, make a prediction just based on those examples, and then interpolate that with your baseline model prediction. And I think all of these are interesting approaches. I think they each support different kinds of interactions and could be really interesting from an HCI perspective. But the one that I'm exploring at the moment is this retrieve and interpolate approach. And this comes from a paper called Nearest Neighbor Machine Translation. I'm going to give you a super quick, hopefully not too quick, introduction to how these models work. So these models work at a generation step by generation step level. And so here we've got a source language of French and an output language of English. And our test input down here, I don't know if you can see my mouse. Can you see my mouse? Yep, cool. So our test input down here is here, and then we've generated I have, and we're trying to generate the next token. And so what this model does is it takes a hidden state representation of this source sentence and partial generation and compares it against an index of a bunch of source sentences and partial generations. But these are generated from sentences in their reference translation. So for these, we know what the next token was in the reference translation. So we retrieve the nearest neighbors in this embedding space, and we aggregate over the next tokens to come up with some distribution over the vocabulary. So just based on, in the paper they use 64, the 64 nearest neighbors to this partial generation, we would expect the next token to be bean with a probability of 0.6, or maybe my with probability 0.4. And then for robustness reasons, they don't just take that as the prediction, but they interpolate that with the baseline, the machine translation model. And I think what's important to look at in this last equation is that there's kind of two competing factors here, right? There's the PKNN is the distribution of the vocabulary predicted by just the nearest neighbors. So this is kind of like, if we just looked at our retrieval outputs, what would we pick as the next token? And then this is the distribution from the model. So what would the model vote for as the next token versus what would the nearest neighbors vote for as the next token? How does this help us? One, it improves performance for domain-specific translation. At least that's what the researchers who proposed this found. They saw a 14.5 BLUE score improvement on a medical data set. So that's very significant. So that's nice, similar to why we would have used a fine-tuned model. But unlike fine-tuning, it gives us a much more intuitive definition of what a good input is. We can assume, and this is a hypothesis that I've been testing and seems to be holding so far, we can assume that the closer a sentence is to the retrieval index, the more likely it's going to be translated accurately, assuming that the translations in our retrieval index are high quality. I might start mixing terms here because the paper uses index, I've been using translation memory, it's the same thing. Okay, so assuming these two things are true, what are our design goals for integrating this into an interactive system? One is to help users write in a way that's similar to the index. And a second is to help users verify translations by reference to the index. So I want to talk a little bit more about these models before I get back to Cephalo. How can we define good inputs? What do I mean that these models give us a more natural definition of what a close to the index means? Here's an example sentence. This is maybe not a very realistic example sentence. I made this up, but let's say it says, please return to the emergency department if you have a headache. And I'm going to show you three different rows here of translations. The first one's going to be the actual output token predicted by a nearest neighbor machine translation model. I'll put a caveat here that this is kind of an early prototype model that uses a very small index. So the translation actually I don't think is that great, but it serves the purpose. And then I'm going to show you the index selected token. So remember I showed you that interpolation equation. We have what the index is voting for and what the model is voting for. We're going to show you the index vote each time and the model vote each time. So here are those three translations. We're now using German. And your first impression from this might be that they look pretty similar, which I think is good, especially considering I just told you the index is quite small. Like this is pretty impressive. But there's three things to notice. One is if you look more closely at the second token, we're going with the index selected token, not the model selected token. A little further down, we went with the model one here. And then there's another one down here where, again, the index selected token is different from the model selected token. I'm a little in the weeds here. Why am I talking about this? Because if you look across the whole thing, we can see that 11 out of 12 of these tokens agreed with what the index said. We know the index is a verified set of translations. We could actually even look at those nearest neighbors and see what the translation was. And so we can say that this translation is utilizing our index quite effectively. Another way of looking at this could be coverage. So when we're taking 64 nearest neighbors, for example, those top nearest neighbors actually really close to the sentence that we're trying to translate, in which case we might think, okay, that's good. We're probably getting really reliable information out of that index, or are they a little bit further away and therefore maybe not as helpful, and we might be getting noise. So these are some ways that I think this model admits like a little bit more of a interpretable and direct notion of what's close to training data and what's likely to be translated well. So we started on this tangent because we were working on Cephalo and we realized there's quite a couple of instances where we're going to need something that's a bit more flexible than a translation memory alone. We talked about a couple of different alternatives. I think these alternatives, particularly using a combination of a human translator and machine translation model, are still very viable. But I also think that retrieval augmented models are a really exciting direction. And I'm excited about the potential for bringing HCI methods to studying how those models fit into these systems. So what does that actually look like in terms of a user interface? I've shown you two different ways that we might provide translations in this system. One is the kind of exact matching approach. So this was what I showed you first. where we take a sentence, we say, hey, we have something really similar to that in our translation memory. How about you use that instead? Because we sent this to a professional translator and we can tell you that this translation is accurate and appropriate for your audience. So that's one approach. But we said, okay, this doesn't work. This maybe works 60% of the time, maybe 70% of the time, right? So what else could we do? We said we could bring in these more flexible models that have natural interpretable definitions of kind of close to the training data or good input. And we could use that to nudge people towards better inputs. This is where I see really exciting potential for bringing HCI and machine learning together, because of course, initially when these models are proposed, you have some static test set and you say, does it improve performance on these sentences? But when we're in an interactive mode, we have the ability to say, okay, maybe your initial, the way you wrote this doesn't really utilize our index very well, but there's a million ways you could have written this sentence. Why don't we push you towards something that's more likely to be translated well, or at least that we can tell you like, hey, this is translated well, or this isn't translated well. So these are early prototypes. We're currently designing this. It's an iterative design process. We'll be putting this in front of people, trying to see, can they use this information? What else could we be showing them? Would love to hear ideas about, different things that you think would be helpful here. But this is where we're at the moment. Okay, so summarizing, what could we do if we had a translation memory for discharge instructions? Showing you the translation when it becomes a retrieval task gives us a much clearer definition of what a good input is, and it gives us the ability to verify it. Going back to this model that I started with at the beginning, where I introduced the gulf of execution and the gulf of evaluation, and we saw that machine translation models alone are not very well designed for helping you prevent errors or recognize, diagnose, and recover from them. So how is Cephalo different? For one, it bridges the gulf of evaluation because you can always see your outputs in English. I think if we're building a multilingual translation tool, we shouldn't be relying on someone who doesn't speak the target language reading the target language in order to identify errors. And it also bridges the gulf of execution better because you can look directly in the translation memory to see what kinds of inputs might be translated better. Either you can take an exact match, or you could at least look at that to see the style of things that we have in our index and know that if you write closer to that, you're more likely to get a good translation. And I think the reason that it does this well is because the translation memory acts as a shared language for specifying and refining user intent. So the user and the system have this structured way of talking about the user's goals that the user can understand, and the system knows how to translate into the output language with really high quality because a human did it, basically, in this case, because a human has already done the translation. So most of you here probably don't work on machine translation. So I want to take this one step up to conclude and talk about how this might apply to the kinds of models you work on. So say we'll go back to this kind of abstract user-system interaction. User has a goal, they're trying to use the system. As a reminder, the gulf of execution is how do I use the system? And the gulf of evaluation is how can I tell if it did what I wanted? So when is it useful to introduce this kind of shared language for specifying and refining user intent? I think it's really useful if your model has complex and stochastic error boundaries. In other words, if it's difficult to concisely explain to the user when their inputs will be well supported or not, or how to use the system or how not to use it. And it's useful if the user can't easily verify outputs themselves. So the key design insight that I hope you take away is that a retrieval index acts as a shared intent specification between the user and the system. And that shared intent specifications don't necessarily need to be a retrieval index, but they do need to be easy for users to learn, use, and verify. And they need to be able to be transformed into the output language with really high accuracy. Once the system and the user agree on some shared intent specification, you don't want the system then introducing new errors after that. Thank you very much for listening. And I want to thank my co-authors on the Cephalo project, as well as many, many other people who have contributed to my thinking on machine translation over the last few years.
Thank you so much, Sam. That was an amazing talk. I'll ask a question and then see if others have questions. But this notion of good inputs, do you think that isn't this notion itself restrictive in the mind of the user? If in the mind of the user, two inputs are equally good, but for whatever arbitrary restrictions of the model itself, when you're suggesting this nudging approach to kind of improving inputs, if the modified inputs are like in the mind of the user are equally good, how does this affect usability? Is this a good bottleneck to work around, or should we actually have better models in the first place that
Yeah, I think there's maybe two aspects to your question. So let me clarify which one you are asking, but I think also both are interesting questions. One is, should we be constraining how people can communicate, or should we just be improving the model? I think the other way of interpreting that question is, what if we make a suggestion to the user of like, hey, this is closer to the index, or this is more likely to be used, translated well, and they can't tell the difference. Like it looks different to a model, but the user can't tell the difference. How do they learn? I can answer both. So I think the first question is really interesting, because when we see people interacting with language models, people have found this across different types of tasks. For example, if you're using predictive text, if I'm predicting some text for you, I'm going to be nudging you to speak in a certain way. And there's pretty serious social implications to that. There was a recent paper at Chi. I wouldn't be able to name the authors right now, but I'm happy to follow up about it, where they found that using an opinionated language model actually shifted what people wrote in terms of how it reflected their opinions. So there's big implications to that. I think, of course, we should keep improving models. I'm certainly not here to say we don't need better machine translation models. All we need is this. I think the better the models, that's great. But I also don't think that we should be putting out models that do have naturally limitations without conveying those limitations to the user. Of course, it's still up to them if they want to use the model in a way that maybe isn't as well supported and deal with the consequences, they are free to do that. But I do think we should be communicating around the errors. To the second question, I think that's actually a big design challenge that I had not thought about, which is, if two sentences look very different to the model in terms of how well it's likely to be translated, but very, very similar to a user, then it kind of makes the learnability of the system a little bit difficult. And I think that's an interesting challenge that actually kind of depends on the error boundaries of the model. And that's just something we're going to have to look into and test through user testing and figure out what we can do then.
And is there an approach where you would you have a wrapper on top of the model that rephrases the input, where like from a usability perspective, like nobody's nudging the user, but kind of you are kind of also adapting the input so that the model I mean kind of I think reduces transparency of like what is actually being input to the model, but maybe like there seems to be like a usability transparency trade-off for such an approach. But is this like something that people have been thinking about for using?
Yeah, I mean a very simple version of that is just autocorrect, really. But you can imagine that if you did autocorrect and didn't tell the person that you're doing autocorrect on the back end. I think that doing that without surfacing it to a user is probably dangerous, because the rephrasing could always contain errors. And so I'm not sure about that, but I do think that doing some kind of automatic rephrasing is similar in spirit to kind of what we're proposing. And I think that surfacing it to the user is probably useful, again, from a learnability perspective. Ideally, if someone is interacting with this system over time, you want them to have an easier and easier time. We don't want to be giving them suggestions for every single sentence they wrote every time. Hopefully, after some time using this kind of system, they would actually just kind of pick up, like, this is the style the model likes, and now I know how to use the system.
Any other question from... Yeah, Marie.
Yeah, I had a quick question aligned with what you were asking. Is there a way that you can communicate back to the user, like how much value, from iteration, t to t+1, if we take again the example of like Stanford in another style, is it that there's a way, very much like, okay, a new patient contributing, that much value in a database because like it makes our estimate of the treatment effect like go in a totally different direction, like basically say kind of continue going in that direction, like the the gradient between that iteration and that iteration really helped the model. Yeah, like, is it possible to communicate back to the user the value gained by the model between like two iterations, like any two prompts?
Can you say more by what you mean about value to the model?
Yeah, like, I mean, it's harder in your case, but I'm just thinking, for example, let's say we have a patient database, right? And I'm receiving like a batch of 100 new patients, and they bring a lot of heterogeneity because I didn't have patients like them before. So I know that this batch, right, was much more useful than a previous batch where I had received the exact same number of patients, but they did not change, you know, the entropy or so I was thinking about something like that could be a value return to the user. Like their prompt was so different, or, you know, like something in the length of the prompt, or that really facilitated, you know, and then the user can say, oh, now I'm happier actually with this image. This is going more in the direction of what I want. Like this is really going to the target.
Yeah. Just to interrupt you for a second. So I think I was going to ask a similar question, which is like feedback. So if you are able to collect feedback from the user, not only you can like fine tune the model and also use the user as the verifier, but also in an interactive session, like in the DALI example, I think what Marie means is like, if you can get feedback on each iteration, maybe you can guide the next prompt in the right direction. That's how you nudge the patient for the next prompt.
Yeah, I think so. What this is making me think of is how we incorporate professional translators into this loop, because if we make a suggestion to a user and we're trying to nudge them towards translations that we already have, but it turns out we really just don't have coverage of this particular, you know, patient's condition or something like that, we can't just nudge them to use a different term if it's, you know, describing a disease, right? We have to then go, we will need to have some kind of backstop, whether that's Google Translate, not Google Translate necessarily, whether that's a machine translation model, or if that's a professional translator, or both. I think ideally we have some kind of translator in the loop system where if we do need to add things, or we want to be continually adding to the index, then we're able to go send that off and add it back. I think that is actually another reason why I think that this kind of retrieval augmented method works well, because particularly the ones that don't require additional training, because it would be really easy to just add in translations whenever you're getting them and improve your model continuously. In terms of like being able to give the user positive feedback for introducing diversity to the model, I think that's a little bit difficult, because I mean, we could tell them like, hey, we've sent this off to a translator and now the system's going to be better next time you want to use this particular context. I don't necessarily know if we can use the user to verify model outputs, given that we then get back in the position where we're dealing with a different target language. I might be, if I'm misunderstanding the parallels here, let me know. I'm happy to. No,
I think that there are like, there's a setup where the user can verify, like the whole point from the system is
exactly,
you know how to translate. But there are use cases like the DALI example where you actually know what you want to generate, and then you can get feedback on the generation.
Definitely.
Other questions?
I had another question related to you know, kind of ongoing, let's say, communication between a patient and a physician, and or in the case of your discharge summaries, writing it like in an empathetic style. How do you feel about like chunking tasks? And I know in HCI that is a topic of research, like how should you like chunk tasks? Like, do you think it's gonna be easier to like achieve the end goal of, let's say, like making a discharge note like more empathetic, you know, or in a certain like cultural style, if you are to like chunk it by replicating, like you're saying, like using this index retrieval, maybe there is a part of the discharge summary that is really about, you know, just reporting which diseases occurred. Maybe there is one part that is about communication with the family, etc. So is it that like this index retrieval should be combined also with the structure of a document? It might be like harder to pass an entire discharge summary and say like, I want it in a more empathetic style or something.
Yeah.
Is it something that like, yeah, you've thought about like the chunking in addition to using prior templates?
Yeah, by that, do you mean kind of splitting it up and then making different kinds of retrieval, choosing different approaches based on what the content is that you're trying to communicate?
Yeah, and also because like Ahmed was describing, I think for these like step-by-step tasks, there's the potential that the user, in that case, I guess, you know, a doctor that would be kind of validating what the other doctor is doing, or I guess, you know, what the doctor robot is doing. There is a way to kind of validate the prior steps before moving to the next, right?
Mm-hmm.
So that could like, it's kind of like chunking a big task into many, so that at the very least, like if you're not passing, you know, the first steps, you're not gonna move towards the end goal. And like there should be like adaptive learning, like for task K in the sequence, it should be easier.
Yeah, I mean, I definitely think if we're building a system like this that is an authoring tool, really, then there's a bunch of potential to introduce different kinds of interventions that could be layered. I mean, I think this comes back to the idea of, could we just rephrase the user's input ourselves and then put that into a translation model? It's like maybe we have some standard of whether it's, you know, simplicity, like writing at an appropriate reading level, appropriate level of health literacy, appropriate level of empathy. I think if we're building out an authoring tool, then it makes a lot of sense to integrate those kinds of things as well. I also think it's a benefit of the translation memory approach that we can make sure that those translations are really high quality. We can make sure that the sentence we have in there might be, for example, I've worked with real discharge instructions, and there's so many different ways that a doctor will ask the patient to please stop using drugs. And I am not a professional in this area, but I am assuming that there are you know, standards around communication, around addiction, and how we can communicate with patients in a way that's more likely to actually encourage them to get help rather than be stigmatizing. And if we have a translation memory, we can actually make sure that all of the entries in there meet these standards. And so if you write something that maybe does sound a bit stigmatizing, the model's suggestion is guaranteed to maybe convey the same meaning, but in a way that maybe an expert in this area has validated, not only as accurate in terms of the translation, but also appropriate for the audience. So hopefully that's related to what you were talking about, but I'm excited about that potential.
Any more questions?
I guess, do you have an example of a system that you would like to implement at UCSF or like any, you know, related hospitals? Like, is this discharge summary a good example?
I mean, yeah, that's my ultimate goal. I think it's a big reach goal, you know. That's implementation is super hard, but of course, yeah, my, you know, dream vision of this project would be that this is actually something that is implemented and people can write their instructions in a way that's going to be reliably translated into different languages. I think organizationally there's major challenges because this kind of tool ideally would be integrated right into an EHR, right? But that's not within my control. So yes, ideally the system that I would love to see implemented is the one that I am building. I'm also excited about other kind of these authoring tools. We use such sophisticated authoring tools in our everyday work, not as physicians. And so many of those things that we take for granted as NLP tools that are integrated, you know, in your email or whatever, are really sophisticated, haven't necessarily been adapted for healthcare settings. And I think there's a lot of potential, yeah, both in a multilingual setting and in the monolingual setting.
I think one final question. like to implement this particular, because we are working on hospitalization related projects. So I'm just curious, if you want to implement such a system, would you need to interface with legacy systems like Epic to enter these discharge summaries into the systems, or can you have a standard system that's...
Yeah, I mean, I'm overlooking the organizational challenges. I'm overlooking the adoption challenges a little bit. Physicians want to save time. If I put a system in front of them that they then have to like go out of the EHR, go into it and type it, then there's privacy issues. So yeah, I think the ideal is that where they're already writing these instructions, this kind of thing can be integrated. That would be great. Realistically, it's more likely would have to be some kind of external thing. The ideal is something like Google Translate, right? The benefit of these systems, they don't give you verifiability, but they do give you simplicity. You copy and paste your thing, you put it in, you get a thing, you copy and paste it back, super quick. Of course, if we're going to do something that gives more verifiability, there is going to be a time element to that. There is going to be an effort and cognitive load element to that. And I think that's going to come down to hopefully good design, lots of user testing, and trying to figure out a way of doing this all.
Yeah. Okay. Thank you so much, Sam,
Thank you for having me.
And thanks everyone for attending. See you next meeting.